Good afternoon, everyone. Welcome to the live lecture for week 11 for the course Computer Graphics and Engineering Drawing. So, this course is being conducted by Professor Rajaram Lakkaraju, and I'm, I'm Sanika. So, I will be conducting this live lecture for the course. So this live lecture is meant for doubt solving. If you have any doubts during the coursework, so right now during the week, it has been about the SolidWorks software. So when you will go to some company, when you join a company, most of them will use some kind of CAD softwares, computer aided drawing software like SolidWorks, Creo, or CATIA to design their parts. So if you have expertise in using these softwares, that will be a added advantage, and your CV will be more relevant to such jobs wherever CAD/CAM designing is involved. So when I joined as an intern in a company, so there I was asked to use all the SolidWorks skills to make a bulb bulb casing actually. So um, so there I learned that whenever you start working with the SolidWorks model, earlier it was a trend that just you should get a 3D model out of it, but now the trend is changing. There is design for manufacturing trend that is coming in. So even when you are designing that part, even then at the back of your mind you should have that thing that how would this be actually manufactured. So there are different options in the software SolidWorks, where you give extrude, where you drill holes, where you will make the threadings, where you will give surface finish and all those things, or even the chamfer. So when you are making that object, you should first think, plan how you want to go about it, and then jump into making the actual model. There is one thing that when the product is in designing phase, in that phase there might be some some unexpected changes. So in that case you might not be able to give a perfect design for manufacturing model to the manufacturer. But in case the model is quite finalized, this design for thinking model design for manufacturing model will be more useful for the manufacturer. So for example, I will share my screen here. So in this screen now I'm going to make a pipe joint over here. So I've already started sketching it. So what I actually want to show is that I can vary all these lengths by just clicking on them. So what I actually want to show is, after this is constructed, you will this denotes sketch 1. As soon as I give it some kind of extrude or loft or something, immediately that will appear uh, in the left part of the screen. So when you are designing it with design for manufacturing in mind, then what you can do is you can simply move this thing top and bottom to hide the features that are below this and show only the features above this. So in a way, it will be like, uh, first, you will make a hollow pipe, bend it, you will bend it, and then you will give it a surface finish, and then you will do this, and then you will do that. So, all those kind of things can be imagined with a single file. So, let us start with making a simple flange, maybe. So, delete, I will just select and delete whatever I had drawn earlier, and let's just try making a flange. So, uh, if you are making a flange conventionally, like using a lathe or something, then you will have a die stock with you. You will have a bar stock with you. So here again you can see in the left, I can see there are two types of circles that I can define. So this is center and radius. This is 1, 2, 3. That is a circle that passes through 3 points. So depending on how you want to use it, you can choose one of the two options. So here I don't have any 3 points where I need to match the circle, so I'll simply take the circle and radius one. And to define this, now I will uh, measure its radius. So I'll put it as, let's say, 400 mm. So 400 mm is like 40 centimeter. That is actually too large. So let us imagine a flange of a car wheel. So I think that should be this much, which is around maybe 80 mm or something. So the smart dimension is a really helpful thing because whatever circle diameter you draw, you just enter a value here and your circle will become of that diameter. So you don't have to actually measure it while you're drawing it. So, uh, since I want to make a flange, which will be as a bar stock initially, I will simply extrude this. So, this comes in the features part. So, I was in sketch right now, and now I'll go to the features part. So, I will ask for extruded boss or base. So, here I will select. Now on the left side, I get all the features that I can select for this extrude option. So here the sketch plane is already, it has already selected the sketch plane. D1 is the thickness of the extruded material. So let us say I will take it as, again 80 mm, or maybe let us take it as 100 mm. Okay. Now, uh, I am using the scroll key here to zoom in and zoom out. So those of you have used both AutoCAD and SolidWorks might realize that what zooms in you like the if you rotate the scroll key towards you, it might zoom in AutoCAD, but it is the opposite in SolidWorks. So it's very troublesome to use SolidWorks and AutoCAD simultaneously. Okay, so in the left side here I have D1. They have a option of having direction 2 as well. Like you can extrude it on both sides. So if you have this plane defined from where you want to go up and down, then you can have this direction 1 and direction 2 also. Or if you want to change the direction of this current cylinder, you just have to click on this arrow. It will. You need to click this to reverse the direction. So let us keep it here for now. And direction 2, I don't want it, so I'll just unclick it. If I click on direction 2, there is a small extension down below which I don't want right now. And then once I'm done, I'll tick mark it. So now you see here on the left side, I have this boss extrude one. So I can always go there and right click and uh, rename the this thing, the name of the feature. So if you click here, like if you click on the down key here, you can see that there is only one sketch that I have drawn here. If you again close that, you just have the boss extrude. Now what I'll do, uh, first I will uh, cut out a cylinder. So I will make a flange which has base of 80. Then I'll have a cylinder of 50 and a final diameter of 20. So now I want to remove all this material and have a base which is 80, and the next step of the flange I want it 50 diameter. So what I'll do is I'll select this plane and I'll go to sketch. So there I'll draw a circle which has radius 25. So right now I didn't have to measure and leave the cursor. I could simply draw a circle. Now I'll go to smart dimensions and just click on the uh, sketched entity, and I can type in 50. So it automatically will go to 50. Now you can see that since this has become black, it means that it has been fully defined. So now I want to remove the material, this part of the material I want to remove, and I just want the center part. Till where I want to remove, let's say I'll have 20 mm of 80 mm diameter over here. So I will remove of 80 mm material. So now extruded cut option is there. So I will take this and so here is where I can select the uh, plane which will get extruded. So I don't want this plane, I want this plane to be selected. Alright. So and the length will be 80. Let us see what this gives us. So we wanted the opposite. So nothing to worry. You can edit it anytime. So now on the left side you see there is cut extrude one. So you just right click on it, you say edit feature, and here uh, here when you select it, you select the outer portion. I guess I'm doing something wrong. So let us just so the selected contour I want it as this one. So here I had option selected contour. Uh, so let us just check now what it gives. Yeah, now it is correct. So this is cut extrude option, and if I measure the length from this face, to this face, it will be 80. Now again I'll do a same operation where now I want the 50 mm dia uh, for, let's say, again 20 mm length. So again I will select this surface and I will go to sketch. So once you start sketching, you can see that on the right side, here on the right side you can see these two options. So this means that you are still in sketch. So if you have come out of sketch, if you come out of sketch and go to features, all the features are available. But if you are in the sketch, some of the features are not available there. So I'll just double click on this one, because I wanted to edit it. So sometimes it will become really difficult to actually go and click it in the object. So you can also select these objects by clicking over here. See, if I click on the cut extrude option, what I saw is this surface that I cut extruded. If I click on the boss extrude, it will show me the surface of the original bar stock that I had. So this is a simpler method to select objects. And if I double click here, it is in sketch right now. So now I will go to features and I'll do extrude and cut. So again here I need to select the contour and I'll select the outer one as my contour, and for length I will now again give 20 mm less, which is 60 mm. Okay. So this is how my flange is going to look like. So, if you want, you can give another small cut over here. This will go on. So, let us say you want to fix this in some motor or something. So, generally, a curved surface is difficult to fit in because it is symmetric. There is nothing stopping it to rotate about its axis. So, generally, the flanges have a cut on in the cylinder. Hmm. So now I've made this plan, and usually here this part this part will have a fine cut over here. So for that, you if I want to create a cut over here, I'll have to first define a plane where I want the cut. So I will go to surfaces, or there's another option over here which with which I can draw planes. So there are a lot of options available here, like I'm showing you. So here you can uh, you know generate new surfaces, and So orientation and all you can check from here from top. So this is actually a good tool for those of you who are having trouble imagining the objects. If you go to this plane, you will have a side view. This is how our flange is looking right now. So what I want to do is define a new plane here. So every this thing, every SolidWorks version has different set of uh, menu. So let's just try searching it here. So you can always do this. You can go to net and search for different uh, features that you want to use. There are lots of videos available uh, for every feature in SolidWorks. So here what I wanted to show you is if I just pick this, you can see in the left, if you just pick this one and you do this, then the recent extrude has got hidden. If you do this and go here, the second extrude also has got hidden. So this way, so this is the original bar stock that you got. Then you do the first cut, you get this, and you do the second cut, you get this. So this is how you can have the design for manufacturing thing. So here, if you go one place on the top, one place on the top, you can see how the object was looking before, and you can go to that place and change some parts if you want to, and that will be easier for the observer also. Instead of random fillets and cuts and things here and there, that is a better option. So if you want to rotate the object randomly, you need to press the scroll button, not scroll it, but press the scroll button, which is the center button, and then rotate it as you want. So let us try to give a chamfer here in this place, which is usually a place for stress concentration. So if I go for features, I'll find here a lot of options. I have fillet over here. I have, you can use n number of options here as per your requirement. So that is why there, since there are so many options available here, before you start making a drawing, you should plan from where you want to start. So now I'll give a fillet here. Radius, it's taking 10 mm. I don't want it that high, so I'll reduce it. I'll make it 5 and I'll click. So this is the fillet it created. Similarly, I can create a fillet over here. The settings are already there. I've just in the left here, items to fillet, I've chosen this edge. If you choose this edge, it will also come there. If this, it will also come there. In case you want to clear the selection, right click on the selection, delete. So the third edge has got deleted, and I simply tick mark. I'll get the filleted uh, flange ready. So in case now see, the fillet has come over here because I did it right now. If you want to move it above, you can move it. So if you want to put it here, it will go there simply. So it all matters which fillet you see first when you keep on hiding the recent uh, features that you have added. So now in case you want to change the fillet radius or something, then you can simply right click on the fillet option and say edit feature. So here you can either select, deselect, you can again profile. This is circular profile. There is a uh, radius that you can change and all. So all these things you can keep editing as you go. So SolidWorks in it is a very easiest software I have found till now, and we used to use this in our labs to design the robots. So that's where I learned SolidWorks. Only practice can help you to actually use this SolidWorks as a good tool. So I think uh, if you want to have a good expertise in SolidWorks, you can go for maybe some certified course by a proper proper certification is available, and that can help you to get jobs in, when we go for laser cutting or when we go for machining. If there are CNC lathes available there, usually they'll have the 3D models directly given to them, which they directly convert to the STL file or something, or maybe directly they get a code out of it. So these are the places in the shop floor where directly just the knowledge of SolidWorks can be used. Or else there are companies, a desk job where you can actually design using the software, because everything cannot be drawn with hand or everything cannot be molded with sand. That is too time consuming and wastage of time. So this can help you with imagining different things, because to tell the ideas, it's always better when you have things in front of you. So when you want to communicate with the customer or when you want to communicate with the manufacturer, giving a 3D drawing is really helpful. So recently I think SolidWorks had launched a 3D PDF wherein uh, you can actually have the uh, 3D model in the PDF, because PDF is a shareable format. So you can have that model in the PDF and people can actually rotate and see the model. But there are not many features for editing and all available there. And in case you have added some cross section there which you want to show, maybe like this flange doesn't have any internal features, but let's say something has a very important internal feature that you want to show, then you can take that section and put that in the 3D PDF. So such developments are taking place. So uh, there are companies like, of course, the Salt System, who has developed this SolidWorks software. So at the back end of the software, all the coding and the curves that you learned in the last week's lecture, the Bezier curve and all those things, those are used at the back end of developing these softwares. And now even there is machine learning getting involved in all these softwares. Like if I'm using extrude option too often, or if I'm using the linear pattern or circular pattern option too often, then the machine learning will automatically get all those features available to you whenever you start working. So there is abundance of opportunities to work in this field. A lot of mechanical engineers are required for such things, because a computer engineer uh, might not be much acquainted with the intricate. details that mechanical engineers want. So there are a lot of things getting developed with these softwares. There's back end part of the software where you will actually uh, make some development, introduce some new feature in the software itself, or you can be at the user end where you are using the software to deliver it, to deliver the design to someone. So, or you can be at the manufacturer's end who is just using this as a output for this thing, for manufacturing. So in SolidWorks, apart from designing, you also directly get the 2D designs. And why 2D designs are more popular is because sharing this 3D file is very difficult, because the size of this PDF, I'm sorry, size of this SolidWorks file is too large to share it with someone else. And on the other end, SolidWorks is I think paid software. So unless it is very essential, no manufacturer is going to buy a SolidWorks software. And on top of that, these softwares require a lot of memory and lot of RAM. So these cannot be run on low end computers. This small object is easy to open here, but if you have some 50 parts in the assembly, or you have a very intricate part which is designed, it is very difficult to use it on a low end system. So for a manufacturer, this kind of investment is not a very, you know, they don't have any incentive to buy all these things. So that's why, to communicate the design with the manufacturer, finally what you need is a 2D drawing. So that 2D drawing can be simply shared as a PDF, or previously it would be shared as printouts. So there is some development that from printouts people have come to the PDF, because PDF is a freely available software. So it is a very common software available with everyone. So you can look at the PDF, and if they want they can take a printout, but PDF is now the more uh, in thing right now. And to go beyond the PDF, like to give manufacturer a better idea of the object, now they are thinking of having 3D PDFs, or there is another kind of file I think they have developed, wherein you can show the 3D objects directly to the manufacturer. So these files, the main feature of these files is that they have low memory space required. So it can be easily transferred through email. So these kind of developments are slowly taking place, but these developments will take time, because those the manufacturers who are at the user end of these drawings still do not have the facility to use the uh, higher versions of the drawing, like 3D drawing. It's difficult for them to view.